welcome here. And okay, let's start. Let me introduce ourselves. So there is with me Massimo. So Massimo Pagani is our product manager and the customer support. He has a very long experience in electronic devices and also now in processing industries applications. More than 20 years experience, and is also functional safety engineer of SIS. And myself, I'm the OKOGAWA account manager. I work in GMI since 2015, and I'm responsible for many accounts, also responsible for European customers. And my experience background is in safety, in machine automation, and safety applications. Quickly about GMI, what is, so it's a company that started in 1993 as GM International, that is the real name of what we call GMI. But we have a very long experience based on former Icon Instruments company. We are mainly dedicated to the physically safe and certified devices for most critical applications. This is the product range. So we have intelligent safe isolators, safety relays, isolators, safety power supplies, multiplexer safety for zone 1 application, termination boards for DCS manufacturers, HART multiplexer for HART communication, surge protection indicators, and also books, because we provide services for functional safety. That is our manual for users. If you want a copy of that, just ask us and we will try to send it. We will send, of course, a copy, both in electronic and paper formats. About certification, of course, we adhere to the most severe specification worldwide. We test in different 15 laboratories. Accredited laboratories, and also we have a functional safety management in place as a company and safety systematic capability. That is our really strength, because we have certification for all possible markets in the world, let's say in America, Brazil, China, India. We do have Japan as well, and Russia. So we believe a lot in a new product, new solutions, so we invest a lot of our turnover in our, let's say, turnover in the new products and development. We also provide 5 years warranty for all products. As we said, we produce completely in Europe, specifically in Italy. We have our factory. We have complete traceability, full testing for all products, and a very automated production. We also really believe that we have to do something for this world and make more safe for introducing new safety capability in our device. That is our presence in the world. So we have different subsidiaries, distributors, people, and some labs about HMI. This is also the name of our main customers. So we are providing product to the main system vendors, the EPC, and engineering procurement construction company, OEMs, people that realize product with our product inside. So, and the users. That is more or less the list of our products. I don't want to tell you any more about GMI. Now is the time for the real topic today, which is a smart relay application. But first, we have a poll. Please, if you try to answer to this poll, just to understand what is our what are our activities today. So what kind of relays do you, let's say, specifically use? In the meantime, I see that you are using Q&A. That is the button, let's say the button where you have to use in case of question. Okay, so we try to answer in the meanwhile. And okay, thank you for answering. I see that most of you use both relays. I can stop now and I leave Massimo to the presentation.
Okay, thank you, Andrea, for your introduction. And we start with our presentation. The purpose of today's presentation is to specifically present smart relay and their field applications based on the experience collected by GM International over years. What are the specific points of today's? The first point of today's presentation is what are smart relay and what are the specific models of GM International portfolio. After that, it's important to understand why choose a smart relay compared to a standard safety relay. And finally, where smart relay are used and what are the typical applications. In the specific case, we will examine application as normally energized solenoid valves, strobe and beacons for fire and gas application, dual tone sounder also for fire and gas application, high availability double coil solenoid valve, single phase load interruption solenoid valve. Well, next, what is a smart relay? The smart relay is a relay that guarantees a specific safety function, like a typical safety relay, but in addition, it has the ability to perform a complete field diagnostic. For complete diagnostic, we mean a diagnostic that includes completely constantly monitor of line and load functions in both operating condition of the relay, on and off status. In fact, the diagnostic of a smart relay is able to monitor the functional parameters of field device and the line, both to know in the real time the health status of the loop in the condition of the load energization, and as a predictive function to know whether in the event of a request for intervention, the devices in the field will activate correctly. This is very important, especially in fire and gas application safety system. We can say that the smart relay combines the basic functionality of the safety relay with a complete line and load diagnostics. Next. Specifically, we will take an example, the most complete of GM International Smart Relay range called D5294S. This model will onboard the most complete of fully programmable diagnostic circuit. This model is suitable for both normally energized and normally de-energized loads, with the possibility of completely configuring the diagnostic section. When used with a normally energized load under normal condition, the contacts are closed. They open on demand to bring the load to its safe state, load off, for example, a valve that needs to be de-energized. The particular composition of the internal contacts arranged in a matrix consisting of two contacts in parallel with each other, plus two other contacts in parallel also with each other, and placed in series with the loads, makes D5294S robust to a single relay fault. In other words, even in presence of a single relay fault, for example, a contact welded, the D5294S is still able to satisfy the safety function. For example, to open the load on demand. In addition, thanks to the contact matrix, the D5294X exhibits high availability to the process, In fact, if a contact opened by accident, the parallel contact redundancy allows the module to continue supplying the load. The loop is still under service. When used with the normally de-energized load, under normal condition the contacts are open, they close on demands to bring the load to its safe state. In this case, load on. For example, a typical application is the beacon light hub. Even in this case, the contact in parallel in the redundancy makes the D5294S robust to a single relay fault. In other words, even in presence of a single relay fault, contact does not close. The D5294S is still able to satisfy the safety function, in this case, to close the load on demand. The fault of a single contact of the matrix is not sufficient to cause a dangerous fault. Next. The D5294X exhibits high availability also in normally de-energized application. In fact, if a contact is closed by accident, for example, due to a vibration, the serious contact redundancy prevents the load from energizing unintentionally. Well, we can say that in the safety relay, smart safety relay, two different safety functions coexist inside. The first and also the main function consists in the input to output or coil to contact activation deactivation. This is the typical function of the safety relay, which upon request is able to drive a load applied to it in a safe state. The second one, the second safety function inside the smart relay is the diagnostic function. It provides full measurement, voltage, current, resistance, air leakage of the load, also through MODBUS protocol, and it can activate, deactivate to fault dry contact. Next. Next again, Andrea. Okay, thank you. The smart relay is equipped with the fault relay, and any anomalies can be acquired through the MODBUS protocol. The smart relay is also available for installation in hazardous area, to be precise in Zone 2, Division 2 for North America. And we can also say that the main function, coil to coil, or coil to contact, is certified seal-free, while the diagnostic is certified seal-2. Let's analyze the diagnostic section of this smart relay, checking what this functionality allows us to monitor. Well, the smart relay is able to detect a line and a load fault, both in energized relay condition and in de-energized relay condition. What can we monitor when the relay is in on state? For example, a typical application could be the monitoring of a normally energized valve. Well, when the load is activated, the D5294S is able to monitor continuously the voltage applied to the load, the current flowing through the load, and also internal coils integrity. This specific model of smart relay has the possibility to performing an internal diagnostic of its coil, and in the event of a fault, report this fault to the system. And what can we monitor when the relay is in the off state? typical application is fire and gas, where we need to know the health of the field loop. Well, when the load is deactivated, the D5294S is able to monitor continuously the power supply voltage, the load resistance or load impedance, the leakage from the load to the ground. In this case, the relay can monitor the leakage resistance between the earth and the load. Well, let's see specifically how the relay can communicate with the system. How and what are the ways in which a smart relay can communicate with the safety system? Smart relay can report the field status to the system in several ways. The first, the two-fold contact can be acquired by a system digital input card. This is the typical way, which implies the use of a DCS with a dedicated DE card, where the status of the contact called a fault is monitored by the system. The second method is the system digital output card driving the smart relay support parts testing. The fault in the field can even be mirrored directly to the digital output without the need of an additional digital input card. This feature will be investigated in more detail later. Other feature is complete diagnostic information can be retrieved through MODBUS multi-drop RS485 protocol if a MODBUS master is available on the system side. Remember that through the MODBUS protocol, the relay can be constantly monitored and also configured remotely. And again, the fault on bus can also be acquired by a system digital input card. The fault on bus is normally used when a cumulative report from many modules is required. And what are the reasons that make us prefer a smart relay to a regular safety relay? Why going for a smart relay? Nowadays, a full diagnostic is typically required along the full loop. However, many widespread systems do not support diagnostic inside their digital output card. Smart relay makes diagnostic available to the system that not support it. Many modern systems do support the digital output diagnostic. However, in many applications, they cannot directly drive the load because they are voltage and current limited, typically no more than 500 milliamps at 24 volts. Or when the load, the valve, vehicle sounder, and so on require more than 24 volt and or more than 500 milliamps really are necessary. Yet when using standard relay, the digital output diagnostic pulse testing dies at the relay coil and cannot reach the load in the field. As opposed, the depth smart relay can go beyond the typical voltage current system limitation while keeping the full load diagnostic. Even if modern systems can perform load diagnostic, their capabilities may be limited. For instance, earth leakage monitor may not be support or extreme loads, for example, beacon may always be reported as an open circuit to the system. Smart relay may offer a solution to extend the digital output diagnostic capability. Smart relay may offer a solution to extend the digital output diagnostic capability. In the following slide, next, Andre. In the following slide, we briefly see the models and the diagnostic capability of the GM International relay seen so far. In this slide, we see in ascending order of the diagnostic functionality a series of GM International relay, all high availability to the process. From the D5094S, D5095S safety relay without field diagnostic, but with high availability to the process, thanks to the internal contact metrics. The 5096 and the 5097 smart relay effective cost, which combine complete load and line diagnostic with preset value. And again, the series or fully configurable smart relay with the possibility of MODBUS communication, detection of an internal fault related to its coil, and monitor of the earth load leakage resistance. In the next slide, let's see in more details what is the mirroring function on a smart relay. This function allows us to reflect information relating to the field fault directly to the supervised digital output card of the PLC. This in the off state through the pulse test system, and in on state by reading the static return of current. The digital output card of a PLC system can detect the information related to the field. The system, through an upward impedance variation of the relay input circuits, allows the supervised digital output card to see the fault in the field. The system allows considerable saving in engineering costs, as it allows us not to use a dedicated digital input card for this purpose. Well, Andrea, I finished my presentation.
We do have another pause. If
yes.
you'd like to answer, is what kind of features are the most relevant for you? Or what, based on the presentation made by Massimo? So take your time, maximum 1 minute, and stop. I see also one question. Also one attendee answer live. Thank you. Use your poll. Okay. Let's wait another few seconds. Okay. So more or less past testing compatibility and fault mirroring on your card are the most relevant for you. Okay, stop now. Thank you very much for answering, and we go through the presentation. So let me see now.
Sorry, but we have a question from our attendee that asked to us a fault mirroring on DO contact. Well, the answer is yes. The fault mirroring is able, the smart relay is able to mirroring the field fault directly on the digital output contact of the PLC through the variation of the input impedance.
I find Massimo for real world application means that we want to show you some application we realized during the years with different systems. So, and that is the field devices we are driving with the safety relays normally. So you can have a Normally-Energized solenoid valve, which is the most common, would say. Can be strobe beacons for fire gas application. That is also, let's say, really particular application, but because of also regarding the impedance of those devices. Dual tone sounder for fire gas application. And high availability double coil solenoid valves. That is also very, very particular. And the last one is the single phase low interruption solenoid valve. So we have an example for each of that. So if you want to take your time now to look at that. So we have a system now, in this case, the Emerson DeltaV-SIS, we are talking about safety application. And then there is a solenoid valve to be driven by the system. In this case, of course, the system is not able, for different reasons, as Massimo explained you, but directly the solenoid valve. So we use the interposed relay, the smart relay, which is the 5294 or 5096, with differences between those devices. And that is an application. So in this case, we need the power supply, the system is driving the load, and the relay is driving the load directly, and the feedback is sent to the relay that is sending again to the system. That is an application. And in this case, we can see, so we have the Normally-Energized. In this case, so the system is off, as you can see, and the contact on the load are open. So let's see what happens in normal condition. Normal condition means the system is driving the load, is acting on the coil, on the relay, and all the 4 relays are being closed. In this case, the load is on, and the flow goes through the load. That is the typical application for this case. So this is normal condition. The safe state means that the system opens, and all the 4 relays open simultaneously. That is the application. We decided to put inside that kind of matrix relay because, as Massimo explained, there is more, and there is, so we assure the safety, but we grant high availability in case you will see later what we have. So the fault, we can simulate one fault that is an open circuit in this case. So the system is Normally-Energized, but the open circuit happens on my system. So I see that what happens. So if the system is opening and the circuit is not anymore activated on my valve, and this fault is reported to the system by digital input. And however, of course, this is did by the 5096, which does not support the MODBUS. So in this case, the fault is reported directly to this digital input to the system. If I'm using for the same application 5294, in this case, the fault is only, let's say, communicated also by MODBUS. So I see that is reported to the digital input, typically, but it's also acting on MODBUS. And the MODBUS master, the PLC, the DeltaV-SIS, is in this case acting as MODBUS master. So it's retrieving all data regarding the fault. The advantage for that, and is the digital input is, I will tell you later because it's interesting. So I can simulate another fault, which is a short circuit, and I use in this case a 5096, which is not supported the MODBUS communication. And also in this case, a short circuit is reported to the system immediately. And so I know that I'm having a problem on my load. If I'm using for the same condition the 5294S, in this case, also the short circuit can be transferred, short circuit information fault can be transferred to the system by MODBUS interface. As for the other. Again, note that you see there is on digital input, I see there is a fault, but on MODBUS communication, MODBUS port, I can note that there is a short circuit. So the difference is that digital input gives me just an information about the fault. So as we see from this application, I can note that there is an open circuit and short circuit, but I cannot know what kind of specific fault I can have at that time. Okay? While with the MODBUS, I can really read the register of the faults. I can know that I know exactly what kind of fault I will have at that time. So I know that there is a short or open circuit. The MODBUS is much more evoluted as information than a simple digital input. So let's continue. So you can have for the same say information for fault on the power supply, and that is of course reported to the digital input to the system, the 1596. And if I'm using again the 5294, I can note that this is reported for mode. So based on your application, based on your system, you can decide either to use the 1596 or the 5294. 5294 is much more evoluted with the MODBUS interface. Also, the other interesting information is the internal coil fault. So I mean that one of relays inside 1 out of 4 is failing, and this information is part of the system. This is not compromising your application, because you see your system is still available, your function is granted, but I know that there is a fault on my internal relay. So in this case, other fault tolerance is equal to 1. Let's make another application that is with the DCS-800 from ABB, and we are in this case driving, controlling beacon strobe for fire and gas application. And this is a very, let's say, just one page. And I see that the functionality with that is I can detect faults. That is the power supply faults for the beacon, of open short circuit, earth leakage, and the internal coil fault. Also in this case, the 5295 is the relays used. It's like the 5294, but with the opposite position for the relay. And in this case, you see that I'm using also the fault mirroring on the digital outputs. I'm not using digital input, traditional digital input card for fault information, but I'm using digital output as just change the impedance on digital output that will be detected as fault. Another application has been made with Foxborough, Schneider, DCS. And there is a sounder that is also interesting because it's critical, it's specific because here I have a dual tone sounder. So I have a dual tone that is reporting different type of alarm. And in this case, I'm using 2 relays for this application. Relays that are granting the different alarm functionality. So also in this case, power detectable fault are power supply fault, open short circuit, internal coil fault. I said only the internal coil fault is only available as information on the 5294S or 5295 because it's the only one that is able to detect the coil fault. Another application has been made with YOKOGAWA, ProSafe-RS, and it is a double coil valve application. And it's quite interesting because here the double coil are using really, it's a critical application, a large compound where we have the valve as a dual coil, and the functionality for the valve is assured by just one coil. So I can have one fault or one internal coil for the valve, and my valve will continue working. What happens? The important thing is detecting. We are able. It's important to detect the functionality of the the good state for the double coils. If one coil is not working, is damaged, I have to report this information to the system in order to repair or replace the valve itself, the solenoid valve. And this information is also reported from the safety relay 5294. So it's able to check internal coil, and that is reported as a fault to the system, as for the other applications. In this case, it can be reported through digital input or through MODBUS. The last application is with the Honeywell DCS 300. In this case, it is another solenoid valve. And what we did in this case is single phase load interruption. So you see that I'm able to connect the valve through a single phase. That is say, when you have the load which is very far away from the cabinet, is common to use just one wire to wire the load. And we are talking now here about low power loads. In this case, we can use it, and it saves a lot of wiring. In this case, I can have the same let's say, alerts on my loads, and but I have just one wire which is connected to the load itself. So in this case, also power supply fault is detected, open short circuit, internal coil fault, and the MODBUS interface also for the 5294S. So now we have talked about two types of relays, and especially 5096 and 5294. And why it's important 5294? Because it's the only one, on our experience, that is can detect really critical fault on the loads, because it is configurable, completely configurable. And Massimo now will show you how you can configure and what you can configure on this relay. It's Massimo.
Yes, thank you, Andrea. Yes, the D5294S and the D5295S can be configured when the parameters to be monitored are really specific and the alarm trigger is not achievable with standard monitor relays. It's also possible to monitor the status of the loop in real time with the configurator. And through a dedicated software called SWC5019 and a small hardware interface, we can completely configure the module. For example, we can set up a window in which the value of the voltage on the load, current flow in the load, and the impedance of the load are included. In this way, when the measurement of the variables in the field come out of this window of configured values, an alarm is reported to the system. Well, in the next slide, through the configuration software, it's also possible to read in real time the value of the voltage, current, and load impedance. A first example is what we see in the slide, where an impedance solenoid valve of about 100 ohm is monitored together with its current. In the specific case, the failure of a coil inside the relay causes redundancy to be lost, but the relay signals the anomaly while still maintaining the energized loop. This is possible thanks to the contact matrix inside the relay, which guarantees us high process availability. Next. In the larger industrial compounds, refineries, and so on, double coil valves are normally controlled by a single digital output driver. The double coil avoids false trips, keeping the system active even if one of the two coil fails. In this context, the D5294S is again an optimal solution because it can detect the opening of the single valve coil, hence providing predictive diagnostic for prompt maintenance while keeping high availability. Next, here we have the example of monitoring and firing gas system, where a partial short circuit affects the winding of the solenoid. This is the typical case where the setting of a specific threshold within which the load impedance value must fall can be monitored. When the impedance value falls outside the set value, an alarm is detected. Note that the 5294S can set impedance value between the range of 5 ohms and 50 kilo ohms. Well, the Rela modules D5294S and D5295S support MODBUS communication over an RS485 cable. In fact, up to 127 modules can be arranged in a multi-drop network and monitored, configured by a single master unit, as shown in the following picture. Each slave contains a table of parameters. Each of them is unequivocally identified through an address, and when requested, makes available its value for reading or writing. What are the advantages of using MODBUS communication? With a single MODBUS RS484 interface, it's possible to connect and communicate with all the relay present on the same bus. And again, multi-drop connection is with multiple multi-drop connection is possible, and communication can cover a distance of up to 1,200 meters. And another advantage is the possibility of not using a dedicated digital input system to monitor alarms. This allows us to have a significant saving in terms of cost and real-time information on the type of alarm and on the health of the load and the line. And again, it's possible to MODBUS a complete remote programming of the relay.
Okay, Massimo, there is a question from one of the max number of relays that can be connected in MODBUS. So
as we can say, sorry.
Yeah, you can answer.
Yes, as you can see in the presentation, we can reach up to 127 modules on the same bus. Of course, if the MODBUS master allows us to reach this number of units.
Typically, yes. It's not a problem with the MODBUS master. Okay.
Yeah, well, Andrea, I leave you the words for the conclusion.
Okay, that's fine. I see another question. Thank you. Just fine. So the conclusion, safety relay. So the feature is the call to contact C3, TÜV certified. So we are not certified, but it's the TÜV certifying that function, safety function. So the diagnostic functionality for the 5294-9295 is complete load and line diagnostic, which is CL2, in this case also certified. It's not interfering with the safety CL3 function, so it can be CL2. It's configurable voltage on load, configurable current on load, configurable load resistance, leakage from load to earth, and coil integrity and internal faults. So any single part of the relay inside and for the load can be detected from the diagnostic system of the relays. That is the important things. For the other product, we have in our product range, the load and line diagnostic is limited only to that part: line, open and short circuit, load, open short circuit, and load supply process. So if you want to have a complete diagnostic system, you should use the D5294S or D5295S if you want to have also MODBUS and so on. And also the most important things for those relays that are really the configuration. So sometimes in our experience, we face with some special beacon or sounders with really specific impedance that that could lead to a continuous alarm on your system, even if there is no real alarm. And because the standard relays cannot be configuring, and that value that they are reading is detected as well. So if you are able to use a configurable relay like those, you can discriminate the impedance for the load. The third features is an important thing is MODBUS RTU RS45, so 127 devices connected on the same line. You don't need additional digital input card for detections. And the compatibility with the digital output card line monitoring test passes. That is also important thing. So you, when the passes from the DCS, from the PC cannot be excluded, is always active, that the relay is compatible, so it's not transferring this pass to the loads is not flickering, so that means compatibility. And the last point is also the fault mirroring on the op card. If you don't want to use the digital input for fault informations and you don't want to use the MODBUS card, you can use also the fault mirror on your digital output card. Those are the main features. We have another question from one attendee. How does pulse test work? Is it possible to test a safety relay without disturbing the process? Do we need to wait for process shutdown to perform pulse test? I think Massimo, this attendee is asking for the test proof, probably, or not?
But no, I think that our attendee intend to ask us how pulse testing of the PLC work. In this case, we can say that the pulse test is always active on the input relay line. And if the relay is compatible with this kind of pulse, the PLC is able to perform a continuously check on the line up to the coil of the relay. The second question is it possible to test the safety relay without disturbing the process? The answer is yes, because all our relays are compatible with the pulse test system of the various PLC DCS in the market. And this compatibility allows us to make safe and without disturbing the process of the test of the line. And the last, do we need to wait for process shutdown to perform pulse test? The answer is no. The pulse test is always active on the line, and we can check continuously the line integrity during all phases of our process.
In this case, but if, not clear if maybe is asking for the test proof or the pulse test. In case you are asking for the test proof, our product, as the other, must be supplied with a manual, safety manual, where there is a well described everything about the test. So if you want to perform the test for the relays up to 3 years to maintain certain cellular level, there are two kinds of tests. One is 100%, one is 50%. So 50% means reveal 50% of the possible failures, and 100% of course 100% of failures. In this case, for 100% of failure, you have to disconnect the system. That is the other. For the 50, you still you can continue working and just test a few functionality for the relays. So depending what you want to perform as a test, in case you were asking that. If we did not answer you, please remake your question. Thank you. So we finished with our presentation. We have now our last poll. Thank you for answering. And if you want to make other questions, don't worry, please do it. Take your time and vote your interlocutor today, GMI, if it was good or not. Don't be afraid, your vote is anonymous, so we don't see your name, what you are voting. Thank you. Thank you very much. And I stop here, don't see further votes. Thank you again. And we want to remind you our contact details. And we want to remind you also that all webinars, also this will be repeated in the next future. You can check on our website the calendar. And also this webinar, as the other, has been recorded. So we have everything on our YouTube channel. You can review it or review others. You can forward to your contact if you like it. If you need any specific also webinar on demand, we can arrange in the suitable time, but we can prepare it. And otherwise, you can we have a different webinar dedicated to the other things like IS barrier solutions, power supplies, functional safety, life cycle, and so on. Okay, with that, we finished. Thank you very much again. Thank you, Massimo.
Thank you, Andrea. Thank you to all our attendees.
And we see you soon. Thank you again. Bye-bye.
Thank you. Bye-bye.